All right. So we're good. Cool. So I'm Meg Schwamb. I'm an academic aesthetic postdoctoral fellow at the Institute for Astronomy and Astrophysics, and I had this crazy idea, and Jason's been kind to let me do this. So we're going to tell you about why the universe is cool and weird. So if you have any questions, you want to talk about aliens, you want to talk about galaxies, well, ask other people about galaxies, but you can ask me about planets and things like that. So this is Astronomy on Tap. I actually started this in New York City, and it did pretty well. And so when I started coming here to watch football, it just seemed like fake. So, you know, the name just kind of said it all. So yeah, so we're on Twitter, we're on Facebook, we are online, so there are events elsewhere in the States. This is the first international one, so give it up for that. Yeah. Alright, so I'm going to tell you about tales from the outer solar system. So I actually have a confession to make. I'm not really an astronomer, I'm actually a planetary scientist by training. So I care about planets of all kinds. So dwarf planets, planetesimals, giant planets, rocky planets, planets outside our solar system. I love them all. I'm equal opportunity lover. And why is because I really care about how these things form. How does our solar system fit into this? So I do use telescopes, but I really love planets. So, you know, other people care about galaxies and stars. I don't really care about those. So let me tell you a little bit about the outer solar system and why it's so weird, and we're still trying to figure it out. And actually something cool I discovered just a few months ago, announced a few months ago. Alright, so how does the solar system fit? So, you know, the sun formed and there was this disk of material, and this, you know, that coalesced to form the planet. And at the end of the day, when that was done, you were left with the planets and debris disks. And we see these debris disks around other stars as well. So this is actually a Hubble Space Telescope image, and they block up the star, and you can actually see these debris disks. So these are the leftovers, the remnants of planet formation. But these are, you know, this is this telltale signature that, you know, these systems are trying to form planets. In our own solar system, we actually have that too. It's called the Kuiper Belt, and also the Astro Belt. But outside of Neptune's orbit is a whole sea of icy bodies that are left over from forming the planet. So here's actually a schematic from yesterday. These are all the known objects we know of, small planetesimals moving out of the outer solar system. The circles are the giant planet orbits. That's Pluto, that's the white cross. It's not a planet. Cool. So Pluto's not a planet, but it's still there too. And it's kind of at home, because there's all the sea of planetesimals. So you can see there's tons of things outside of Pluto's orbit, right? In Neptune's orbit. So there's all these objects, you know, and some of them are diffusing in from the Kuiper Belt, and we call those centaurs. You know, how do we find these things? Basically, if you want to look for planetesimals in the outer solar system, these remnants of planet formation, you take an image on the sky, you come back later, and you take another image on the sky, and you look for the moving blobs. So this is actually dwarf planet Eris. We took this image a couple years ago on the Lucia 1-meter telescope in Chile. So again, sort of the blob moving, that's Eris. It's a dwarf planet in the outer solar system. And actually the thing that goes away, that's an asteroid moving faster. So that's how we find these planetesimals, by studying their orbits and, you know, their properties that can tell us about planet formation. So another way that we can kind of learn about these objects is by understanding about their size. So it's hard to do from that blip that's moving. It doesn't tell us much. We can learn something about their surfaces with spectroscopy. If we want to get their size, we can use occultation. So basically the idea is that the planetesimals move in front of a background star and get so by that shadow gets cast on the Earth, and if you have multiple chords, multiple places observing, where they see the event and they don't actually get to see the size of the object. So it's a really nice way of being able to sort of figure out how big these things are. The things are telling us about, you know, other properties and size, how these things are forming. And especially for the small ones, this is really the only way to do it. So this is Charlie. I'm going to get this wrong. Charlie. It's a centaur. If we can get it moving. So it's actually the largest, we think, centaur. So these are these objects that are coming in from that Kuiper Belt. diffusing inward into the inner solar system. We think that these kind of objects will eventually become the short period comets. So things like Halley's Cup, things that come around much, on shorter periods, and something like Hale-Bopp or Ison, those kind of comets. We think these are the sorts of short period comets, not the long period. So it's a fuzzy blob. That's great. It's center. So it's one of these objects, sort of these orange sort of triangles. It's sort of one of these objects from the Kuiper belt that's kind of diffused in. And so they were able to get an occultation, and it looks really weird. So it's one of those things where you observe it, and you go, what the fuck? So they saw this with a telescope. All right. Anyone have guessed what they're seeing? No one's going to guess. Come on, someone.
All right, can you use a microphone by any chance?
Sure, I'll scream.
Sorry to interrupt.
All right, is that better?
Yeah, thanks.
Perfect. All right.
Thank you.
So what do you think this is then?
No idea.
No idea.
Can you tell us what's on the y-axis, please?
Brightness. So this is brightness of the star on the y-axis. The x-axis is time.
The black hole? Absolutely.
No, it's not a black hole. It's rings. So what you're seeing is the small little dip is a thin outer ring, and when the star when the ring starts passing in front of it, you see a little dip. And there's a bigger ring, and then when that passes in front of the star, you get a dip. When the object passes in front of the star, you get a big dip. And then you see the same thing on the way out, right? So then there's a gap in the ring. You see that. You see the starlight again. Then you see the dip. And then you see the smaller. So that's the same way they discovered Uranus as well. Same technique in the 70s. They were watching a star, they were watching our occultation event, and they saw these weird things that shouldn't be there. And those were how we detected the rings for the first time. So that's kind of the artist's impression of what it might look like. There's this little planetesimal, it's got 124 kilometers in size, and it's got rings. So, roughly to the outer ring, it's 405 kilometers. Again, that's, the rings are only 7 kilometers thick, or 3 kilometers, right? So that was detected by watching those things pass in front of the star and blink out to the light. So why is this weird? So, what are the things that we know of rings in the solar system? Anybody name one? What's got rings?
Saturn.
Yeah, Jupiter, Saturn. All the giant planets actually have rings. All of them. So I like pretty pictures. So this is Saturn. This is taken by Cassini. This is one of my favorite pictures of Saturn. So it's behind, illuminating the rings. That's Jupiter. So this is taken with Galileo. So lovely little ring. There's Uranus again. This is taken with Hubble. That's Neptune. And Neptune's rings are actually discovered by Voyager 2. So we can send a spacecraft out to actually confirm their rings. And now this guy. So this is 124 kilometers. There's Neptune. That's the size, scaled, of that object, right? So that's this dude, that green blip, the big thing, which is about 40,000 kilometers, has rings. We have no idea why it is. So only things that we know in the solar system of rings are the giant planets. Yet now this little planetesimal, it's eventually going to head its way into the inner solar system as rings. So what does that actually mean? We don't, we're trying to figure out why it has rings and what does it exactly mean. But this was totally unexpected. So last year when they got this result, they had no idea this thing had rings. Why are there rings? It could be a collision. So it could be that it got smacked into. This is a simulation for trying to explain Pluto's big moon. But it could be that, it got smacked into by an object and that could sort of create the debris rings. And actually, the curious thing is, so things that are like centaurs, like this object, they're rattling off the giant planets. And so, if the ring could actually survive that sort of gravitational encounters with the planet. So it could be from the early ages in the solar system still be around. But the weird thing is, there's that gap in the ring. There's 2 rings, right? So something's got to be creating that gap. What could it be? Well, it might be the same processes that we actually see for the giant planet rings. It might be shepherding moons. And so a moon about, maybe you want to call it a moonlet, kilometer in size, might be actually holding those rings together and making the gap in the middle. So this is Saturn's rings, and this is Prometheus on the inside and Pandora on the outside. And these are two little moons that orbit around and they shepherd the effort. So basically, these little guys keep those ring particles stuck there. And so the only thing that we can think of that could make that gap and even keep those rings alive in the small little planetesimal is probably a moonlet, maybe ice a kilometer in size. So the same kind of processes that are going on in Jupiter and Saturn's rings happening on this such small scale. We don't really quite know why it has rings, but it might mean that there's lots of objects out there with things on such small scales. And that the things that we're learning about from the giant planet are actually can tell us about what's going on in this object. So I think this is one of my favorite new discoveries because it's one of those things where we totally weren't expecting. And now we need to go figure out what happened. So the lessons that we know from the giant planet can help us understand this object. So that's really all I wanted to say, but I think this is kind of one of the cool results of what the hell when you take some observations and get something completely different from what you expected. So next time you look, you hear about an asteroid or a centaur or a Kuiper object, it might have moons, it might have rings, who knows? But hopefully with more of these observations, we'll figure out how many things have rings and why. So if anyone has questions, we can talk about rings and planetesimals and anything about planets. Any questions?
Yeah, I have a question.